and good morning. Let's look at section 20.4. This too is a pretty short lesson, just like yesterday's. Angles and triangles and AA similarity. When you take a full geometry course, you'll learn a lot of ways to tell if shapes, especially triangles, are congruent or similar. If we can tell that two shapes are congruent or similar, we'll be able to use that knowledge to help us solve problems. In this lesson, we're going to take a look at just one way you can tell if two triangles are similar. In the next lesson, we'll apply what we learned to find the height of a tree without climbing a ladder. Now, to begin with, I'm at the top of 393. We need to look at the angles in triangles. Rather than just telling you about the angles in triangle 1, I want you to stop, grab a protractor, and measure the angles in each of these triangles. Add up all the angles in each triangle as is done in the first triangle. So notice, before you do anything, that first triangle they've measured, it's 40, 140 degrees. You add all that up and you get 180. Now I'm just going to go ahead and tell you these other three. If you'd like to stop this and do it, you can. But if you measure these correctly, you would also get 180 degrees on all three of those. You measured them all correctly. So the sum, and you need to know this. This is like big time, like put this like on your forehead or something, okay? The sum of the angles, that means adding them all up, in every triangle equals 180. This holds true for all triangles, not just those up there that are shown. The sum has to equal 180 in order to form a three-sided polygon. Otherwise, you'd end up with more sides, or you wouldn't be able to form a closed straight-sided figure. Now, since the sum of the measure of all the angles in a triangle always equals 180, then if we know the measure of two of the angles, you can figure out the third. For example, in this triangle, the two angles we know total 44, as 22 and 22 equals 44. Thus, the remaining angle must be 136, since the sum of all the angles in the triangle has to equal 180. So, let's look at the very bottom. This is the AA similarity theorem. Are these two triangles similar? Remember, to be similar, all the angles have to be congruent and the sides have to be proportional. We don't know the measure of the sides or of one set of angles, so how can we tell for sure if the angles are similar? Look at the next page. While we could just pick up a protractor and ruler and find the lengths of the sides and measure the angles in the drawing to see if they're similar, remember that this drawing could stand for something in real life. It's not really the drawing we care about, it's the piece of real life these triangles represent. And those are often impossible or difficult to physically measure. For example, these triangles might represent the heights of a lighthouse and a shrub, along with the lengths of their shadows. It turns out that it doesn't even really matter if we know the measurements of any of the angles or sides of the triangles. If we know that two sets of their corresponding angles are congruent, two triangles have to be similar. This is often referred to as AA for angle-angle similarity theorem. So these triangles are similar as two sets of corresponding angles are congruent. You got the 45 and the 90 on both. So two sets are congruent. So according to the AA similarity theorem, then those two triangles are similar. Now these two triangles are similar as two sets of corresponding angles are congruent. The AA similarity theorem makes sense when you think about it. After all, since we know the sum of the angles in a triangle totals 180, we know that if two angle measurements are the same, the third must be 2, or else they both wouldn't total 180. And if all the angles in a triangle are congruent, the corresponding sides have to be proportional. Otherwise, they'd form different angles. All right, let's look at our worksheet. Now, there's only one thing on this worksheet I'm going to help you with today. And it's on the back. So before we get to that, let's go ahead and look at the front page. Kind of walk through it with you. So 1A and B, you have a triangle that's just got two angles measured. You know what to do. You add those up and you subtract that from 180, and that tells you what the last one is, because they all three added up must be 180. Okay? Now number 2 the same, number 3 is pretty much the same, number 4 you're just using the AA similarity theorem. Okay, so all this comes from what I just read to you in that section. Super easy. Just remember, triangle equals 180 on the inside. Must equal 180 degrees. Must. All right, turn the page over. Let's look at number 5. I looked at this and I thought, well, I have a sneaking suspicion that if anybody's going to need help, it's going to be on this problem. So I'm just going to go ahead and nip it in the bud and just help walk you through number 5. So you can use a calculator. So I'm going to pull my calculator up right here and right now. So I will have mine. Now, it says you decide to get a new window. How much will it cost? Considering the following. The window is a rectangle that's 7 feet tall by 5 feet wide with a 2.5 foot tall semicircle window on top. The window costs $5 a square foot plus 11% tax and a flat $100 installation. The installation portion is not taxed. What will be your total cost? Your hint, break this problem down into steps. To that, I could probably say, no, duh. We certainly have to break this into steps. Okay. So let's go ahead and get this thing rolling. So what's our first step? We want to find, let me find my pen here. Where'd my pen go? I don't even know where my pen went. That's okay. Okay, let me go ahead and get this off of here because I'm going to need this. Okay. So we're going to get a new window. How much will it cost considering the following? The window is a rectangle. There's a picture of it. It's 7 feet tall by 5 feet wide, 7 by 5. And then at the top, it's got a 2.5 foot tall semicircle window on top. Okay, so the window costs $5 a square foot. Okay, so we need to figure the area of this window. So the first thing is, let's find, now I gotta find I don't have all my formulas in front of me and I don't have them all memorized like I should because I don't use them all the time. So let me go ahead and get these in here. Okay, so okay. So first, let's find the area of that rectangle, the rectangular part. You know, we're just going to break this up. Now, I know the area of a rectangle is just length times width. I know that for sure. That's easy. So the area of the first part of the window is going to be 7 times 5 feet. So it's going to be 35 square feet. Okay, that's the rectangular part of the window. Feel free to you don't have to follow me. You can just go on if you think you know how, or you can follow me. Now we need to figure the area of the semicircle. So to find the area of a circle, I can't remember what that is. I have it written down here. The area of a circle is pi r square. R square. Okay, so let's fill in our numbers of what we know. Now, pi is 3.14, we know that. Now, the radius of this circle is 2.5 feet. Am I right? Let me look over here back at my page and make sure I'm looking at the right one. That is the, I'm not sure if that's the, let me use my calculator here. I'm not sure if that's the radius. Divided by 2, 1.25. I'm trying to figure out what the radius of that circle is. Yeah, the radius. That's the radius because it's half a circle because the diameter goes all the way across. So if that were a full circle, then the diameter would be 5 feet, but it's 2.5 feet. So then we're going to take 2.5 and we're going to square it because remember it's radius squared. All right, so let's figure this. So let's pull our calculators up here. Handy dandy calculator. I had a daughter who, when she was little, she called a calculator a crocodile. Let's get our crocodile. Well, wait a minute. Let's do this. Let's square our radius first. That would be 2.5 times 2.5. That gives us 6.25, and then times pi. That gives us 19 point, we'll round that to 0.63. And that is square feet. Am I right? Yeah. Now, to find the whole area of that window, we need to add up both areas. So we need to add 35 plus the 19.63. So we get 54. I don't know if we need to round that to 2 or 1. Let's round it just to 1. Let's round it to 54.6. I'm not sure what they want you to round it to. We're just going to round it to 54.6 square feet. That's the area. All right, so we got the area of it. Now we're going to move on to money. So it says we need to know the cost. Okay, and it's done by square feet. So the window is $5 a square foot. Okay, I keep getting interrupted, and I'm starting to lose my voice. I can tell that. Ugh. All right, so the window is $5 a square foot. So we have 54.6 square feet times $5. So it's $273. All right, so that's what the window itself is going to cost per square foot, plus an 11% tax and a flat $100 installation. But the installation portion is not taxed, so we have to add that in last. So we're going to take this and we're going to multiply it by 11%. Remember how to do that? Times 0.11. So that would be 30.03 in tax that we're going to add, plus that $100 installation, and we're just going to add it all up. Okay, so 30.03 plus 273 plus 100. So 403.03 should be our final answer. That should be our final answer. Let me look in my teacher book right quick. Let me find the answer. Hold on just a second and I'll make sure we're right. That would be worksheet 20.4, number 5. No, we got it wrong. 3, 4. I don't know what we did wrong here. We did the area. Half. Oh, I know what we did. I know what we did. I hope you caught this before me. Right here where we did the area of our circle, this is the area of the complete circle. We just need half of that. Dun, dun, dun. Found our error, 19.63. Halving it would be 9 point. Let me make sure that's right. That would be 9.82. Yeah, let's do 9.82. Scratch that. 9.82 square feet. Now, let's see if it changes this number, because this is our all of our area, both of our areas added up. So let's add this up again. So it's 9.82 plus 35. Whoop! Well, I messed that up. 9.82. Okay, that's correct. Actually, in my teacher book, it tells me that we would have gotten 44.81. I'm not sure why I haven't. I bet it's because they just rounded this to 0.8. I bet that's what that was. They just left off the 2 and did 9.8. But either way, but this would be correct. So this number, 44.82, would be the actual, oh, I'm writing in numbers, 44.82 square feet. That's what it would be. So then, rather than being 273 and this, it would be 2 times the 11, whoops, that would be 220.97. What did I just do? The kids got me messed up. So 44.82. Oh, I didn't do the what was it, $5 a square foot? There we go, 224.10. 224.10. Then you'll do times 0.11. 24.65. Then you would add your 100. Then you would add all that up. And that should be your final answer. Let's make sure it's right. That's right. 348.75. Well, in my book, they got 70 cents. I'm not sure where my 75 came from, but anyway, it's Texas. It's always more expensive here. So anyway, that's how we do it. So the only thing that we messed up on here is I forgot. I hope you remembered, and I hope you were telling me, no, you got it wrong. But you may not have. You might have. I'm not sure. But anyway, that was our error, and that's what we did. So obviously, I'm not going to grade that part of it. So in fact, I'm not going to grade this page at all. So anyway, you should be able to do the rest of the page yourself. And that will be all for today. Yeah!